Hello, Marauders. Hello. Here we are at the pep rally having a good time. So hopefully you understood some of that quadrax and making a parabola. We get a little more advanced. Remember the old form we had, vertex form, and now we have standard form? I'll show you how they're compared. We'll deal with something beyond the parabola. And what if it's impossible to factor? This is a 2-day lesson. There's a worksheet, which is very, very challenging questions. It might take you 2 days to figure it out. All right, here we go. All right, Marauders. So I got two equations here. This one's in vertex form. This is in what we call our standard form. Would you believe these are the same equations? They both have squares. They're both parabolas. Remember, first semester we did vertex form. And if I said graph this, you're like, oh, I remember how to graph this. This is vertex form. These are easy. You would look at the x and go, what makes him 0? What would wipe him out? What's the opposite? Wouldn't you put in 3 right there? And then if you plug in 3, 3 minus 3 is 0. 0 squared is 0. Take off 1, like if you made a little table. That's gone. You can't get any smaller than making this 0. Then down 1, and you said, okay, I'm going to go 1, 2, 3, down 1. That was the vertex. And then he's a happy parabola. Like that. Of course, I should go 1, 3, 5, but I don't have my graph paper. That's called vertex form. You find the vertex right away, but you don't know the zeros, do you? This was the standard form, and we said in standard form, remember, we could find the vertex from this by going minus b over 2a and going, okay, the opposite of negative 6, opposite of b, remember this is a, b, c, opposite of negative 6, positive 6 over 2 times a. A must just be a 1 right here. 6 over 2 is 3. Yep, it's 3, isn't it? See, it was 3. So remember this little rule for vertex if you're in one of these and you don't have this. And of course you plug in 3, and I could plug it in here or I could factor it, but you get negative 1. Now, how is this the same? Of course, this one I could find the zeros, because with this one, I could factor it, x and x. How about 4 times 2 is 8? How about a negative times a negative makes a positive? 4 and 2, minus 4 minus 2 is minus 6. What are my two little answers? 2. Isn't that 2? 2, 0. And what makes this 0? 4. 4, 0. Isn't that 4 right there? There's 4. There's 2. Yeah, those are the zeros. You could actually switch from one of these to the other one. You could change this into this. Here's how it works. Here's how they're related. Let me take this equation here. This x minus 3 squared minus 1. What if you say, wait, square, and doesn't that mean I've got, let's make this part 0 over here. Doesn't that mean I have 2 of these? X minus 3, x minus 3. X minus 3 squared means I have 2 of these. Go ahead and FOIL it. X squared. Negative times negative, positive 9. The middle, minus 3, and another minus 3, and minus 3. And then over here is a minus 1. Let's put this together. Minus 3 and minus 3 is minus 6x plus 9 minus 1. And that's just plain numbers. X squared minus 6x, 9 take away 1 is 8. Oh, that's this, isn't it? Ta-da! Yeah, so they are related. It's just sometimes you see it like this, sometimes it's all right like that. Could you go backwards? Yeah, you can go backwards, but it's a little more work. It's something called completing the square, but let's not go into that. Do you need to change from one to the other? No, nobody ever really bothers. They're saying, if it's already like this, I'll work it. If it's already like this, I'll work it. I just can't figure out the zeros. Of course, I could figure out the zeros if I go like this and try to start solving it. I'm not going into that. Let's try something else. Let's go to a higher level. Let's do x cubed. This is math 3. Of course, in math 2 advanced, you may get this. 3, that's not a parabola. In fact, if it's got a 3, it's got one less curves than that, or bends, or turns. It's got 2 turns. It's positive. It's happy. But if it were a square, it would be a parabola, wouldn't it? But it's got this. Whatever this is, if it's 3, it means it's got 2 turns. So you're going to go like this, another turn. In fact, this is an odd, so it goes in opposite directions. So this has 1, 2 bumps. This is a cube-shaped graph. You could put one of these in Desmos and check it out. So it's x cubed. And I'm wondering, well, if this were on graph paper, it's got 1, 2, 3 zeros. 3 zeros. Because whatever this power is how many answers it has. Let's see if you can graph it. What? Yeah. Now, we're not going to be able to find these without something called calculus. But let's put a 0 here. And we're going to factor it. Okay, 0 equals, well, I can't factor x cubed. I only know how to do x squared. Wait, what do they all have? They all have an x, don't they? Let's undistribute an x. Take the x out like you did the other day, last week. Cube, we took 1, now he's at 2. Square, we took 1, now he's only got 1. 5x, we took his x, now he's only got 5. Everybody loses an x. So they all go down 1. Take off 1, take off 1, take off 1. Now this is important. That has a letter. That is an answer. So let's keep him. And let's factor what's left. So if you see a number, pull it out. If you see a letter, pull it out. Now we can factor this, x and x. We're just going to ignore this part. 5 times 1. A negative. Who's positive, who's negative? You think about it. I'm going to go with negative, because a lot of negatives, and positive. Does that work? You could check it out. You know your foiling. You already know this works. You already know this works. Minus 5 plus 1. 1 minus 5 is negative 4. So now you got your little problems, right? You got this little problem and this little problem and this problem because it has an x and we want to know what x is. Everybody has an x. We're going to get 3 answers. We factored it into 3 parts. We're calling this factoring. Remember, factor means to break it into little pieces, little multiplied pieces. This one, what plus 1 is 0? And you'd say, well, negative 1 plus 1. Let's put that up here on the graph. Negative 1, how about right there? Negative 1 makes it 0. What minus 5 is 0? How about 5? 1, 2, 3, 4, 5. That's a 0. And there's one last one. Hey, I don't have to add or subtract. What makes this 0? What would I put? How about 0? 0 makes it 0. There's no add or subtract, is there? So this would be 0 right here. Boom. And now you're going to graph. Now remember, it's happy. So you go to the end, because if you put a number like 100 cubed, wouldn't it be way up here, like towards infinity? So now the only places it touches 0 is this. There are only 3 answers. You cannot cross here. You have to go down, then back up. You can only touch the x-axis here. These are the only places it's ever 0. You go across, then you got to get back here. And that's the graph. You won't know these, okay? But that's a little more advanced, isn't it? But yeah, pretty cool. Okay, so let's try one that's more complicated. You go, well, it doesn't look too complicated. It doesn't even have a cube. It's just a parabola. Cool. How to set equal to 0? Oh, let me take the 2 out. Wait a minute. I can't take 2 out of that. And I can't take 2 out of that. So we're just going to have to try to factor it right now. And 2x, well, how about 2x times x? 2x times x, 2x squared. Okay, why don't you pause it? You finish it up. All right. Did you do 1 times 15 or did you do 3 times 5? After lots of trial and error, I found out 3 and 5 work. But there's only one way to get it to work, is if I put the 3 here and the 5 there. Yeah, 3 and 5 don't make 7, but let's check this out. There's 3x. 5 times 2 is 10x. If I did positive 3 minus 10, I could get negative 7. So let's do positive 3 minus that. 3 minus 10 is negative 7. And a positive times a negative is a negative. So now we got it. Okay, so here's our 2 pieces, 2x plus 3. And here's our other piece, x minus 5. And we're equals 0. Let's find the zeros so we can make the graph. Oh, okay. What minus 5 is 0? 5. 1, 2, 3, 4, 5. Boop. What plus 3? Oh, wait, okay. Some people get confused, but you can do it in your head. How do you solve that? Subtract the 3. Right? Divide by 2. Negative 3 over 2, or negative 1 1/2. 1, 2, about right there. -1.5. That's the other 0. And it's a happy parabola. Whoop. Like that. So you found the zeros, because we like to know those. The zeros, we want this as a 0, and this is a 0. Some people just do in their head, they just go, what if the 2 aren't there? Just go, well, that would be -3. And I'm going to divide it by 2. See how you do it in your head? Okay, so where's the vertex? Where is the vertex? I'm not sure. Let's do minus b over 2a. Let's do minus b over 2a to get the vertex. So look back at the original question, A, B, C. Okay, so we've got the opposite of -7, +7, over 2 times 2, 7/4, or 1 3/4. Oh, and now I got to plug 1 3/4 in. You could plug it in here, or you could plug it in here. You might even want to get a calculator. We won't finish that right now because that's just going to take some busy work and me plugging that in, but you could. So there it is. What if you were really, really stuck? And you're like, man, no matter what I try, I can't figure it out. Okay. Enter the quadratic formula. When you get really stuck, and of course these were our zeros right here, these were our zeros, sometimes you're really, really guessing. And sometimes you can't even think of it, no matter how hard you try. It might be like an irrational number. There's something called the quadratic formula that'll solve these formula for you. You don't have to factor. You can just plug it in this rule. You're like, why don't I do that? Well, the formula takes a lot of work. Here's the formula. If you want to know what x is, in other words, you want to know what the zeros are, this is the formula. Now remember we had A, B, C? You do this. You take the opposite of B, and then you add or subtract, you'll do both, the square root of B squared subtract 4 times A times C, and then you're going to divide the entire answer, not this, not this, not this, the whole thing after you finish it, by 2 times A. And you're like, I can't remember that. Well, yes, you can. There's tricks to memorize it. I won't go into the whole thing right now. I would do it in class. Recognize that. Isn't that the vertex? Minus b over 2a. And here's a little square house. I have a little joke, but I'm not going to go through it here. Here's a little square house. And inside, here's some boys square dancing. Okay, so you see b squared minus 4ac. All you got to do is really remember this thing. So you put all these in, you get the answer. Okay, before we try this one, let me try with a little easier one, because this one's a lot of work. Let me give you an easier one to try. Okay, earlier we did this one, x squared minus 4x plus 3. And we found out negative times negative was positive, and we found these were the answers. We did this a while ago, and we said, so we had 1, and we had 3, and we had this graph yesterday. But what if you were just, for some reason, you were like, I can't figure it out. Let's put these in the quadratic formula. In this one, a is 1, b is -4, and c is 3. You plug them all in. This is a challenge. This is why I'm giving you 2 days on the worksheet. Okay, so here's the formula. We put in the opposite of b. So instead of -4, you put +4. Some people like to circle them so they don't get confused. Then it says add or subtract. This way we can get 2 answers. Because we do want to get 2 answers. So we'll just add to get 1, we'll subtract to get the other. We do that a little bit later. Put a big square root. B squared. Square it right now. -4 squared. When you square a number, you always get a positive. So 16. So -4 squared, that's b squared. Always put square right now. I see people put -16. No, a negative times a negative is a positive. This has to be positive. Then subtract, you write minus. Then you put a 4. Now you do a times c. Put in 1, put in 3. Don't try to do it all in your head. Okay, now let's finish the bottom. Over 2a. So 2a. 2 times a is 1. Then you have to solve that. And you're going to get these 2 answers. Of course, if you factored them, you're smart. But if you're like, I can't factor it, it's too difficult. This is good if you have some really big numbers. Okay, so let's rewrite this. Big bar, 4. And let's do the bottom, 2. Plus or minus. Now you got to figure out the inside. That's where people mess up. We got 16. Ignore this right now. What if there's a lot of negatives? Just do this. What's 4 times 1 times 3? 4 times, that is 12, isn't it? Okay, so this part here is 12. Now go back and count up your negatives. There's only one, the one that was built in. 16 minus 12, because sometimes you have a negative in here and you might have to go 16 plus 12. 16 minus 12 is 4. Okay. Sometimes you have a number you know the square root of, sometimes you don't. What's the square root of 4? 2. Do not cancel here, okay? 4 plus or minus the square root of 4 is 2. All over 2. Very important you keep this big, big, big bar. Okay, so now you got two things. What is 4 plus 2? And what is 4 minus 2? All over 2. 4 plus 2 is 6 over 2. 6 over 2 is 3. Wasn't that one of our answers? Okay, what is 4 minus 2? 4 minus 2 is 2 over 2. 2 over 2 is 1. Isn't that our other answer? Ta-da! That's the quadratic formula. It took a lot of work, didn't it? Why would I want to know that? Well, it helps when I have a more difficult problem. Like, let's try it with this one. Okay, and I'm just going to put a little sign in here before I get to the end of this. If I wrote 10 plus 20 all over 10, are you allowed to cancel that? Are you allowed to divide? No, dividing takes care of multiplying. This is an addition problem. Isn't this 30 over 10, which is 3? But I see people do this, and you get slapped if you do it. This is bad. Some people think they could cancel. You can't divide an addition problem, and they say, well, the answer is 20. Really? No, that's totally wrong. This is bad. This is 10 plus 20 over 10. You can't divide if it says to add. Now, if the problem said 10 times 20 over 10, you could divide, because dividing takes care of multiply questions. Because this would have been 200 over 10, which is 20. But never, never do it here. Now, you are allowed to say, I'm over 10 and I'm over 10. The reason you can't cancel is this 20 says that's my 10. Now, you could say this is like adding fractions, 10 over 10 plus 20 over 10. Isn't this a 10 over 10 and 20 over 10? You could do that and go 10 over 10 is 1, and 2 over 10 is 20 over 10 is 2, and 1 plus 2 is 3. Could do that. That's going to help me for this problem. Okay, so let's try this guy. This is a lot of work. You know, why? Why? It wasn't too bad. But say I was really, really having a hard time factoring this, or it was impossible to factor, yet I insist on you finding the zeros. I'll talk about that in a little bit. So let's put the numbers in. Opposite of B. B is -7. Some people like to circle them. There's A, there's B, and there's C. A little safer that way. The opposite of 7, the opposite of -7, it always starts out backwards. If you see negative, you put positive. Plus or minus, big square root, square this right away. Who cares if it's negative? When you square, a negative times a negative is a positive. Always positive. You put a negative, you're wrong. Subtract. 4. A and C. A is 2. C is -15. Okay, all over 2 times A. A is 2. Okay, doesn't seem that hard. Oh yeah, this is a lot of work. Okay, we have 7. Down here we have 4. And let's see what we got inside here. Okay, ignore the negatives. Please, please ignore the negatives. We've got a 49. I'm going to write this over here on the side. 49. Ignore these. Don't try to go, is this -4 or subtract 4? Ignore it. Just take the numbers. What's 4 times 2 times 15? Maybe I'll go 2 times 15, 30. 30 times 4, 120. Oh man, is this a subtract? No, no. Count up the negatives. Now count the negatives. A negative times a negative is a positive. So you got to be careful. Sometimes you only have one negative. Sometimes there's 2. Sometimes there's 3. You always get a free one automatically. You'll never have none. Okay, 49 plus 120 is 169. Okay, what's the square root of 169? That's 13. Oh, cool. Hey, this isn't so bad after all, is it? 13 over 4. And now remember, add 7 plus 13 is 20 over 4, which is 5. And 7 subtract, well, I'm sorry, 7 plus 13 is 20 over 4, which is 5. And 7 minus 13, that's why we call this plus or minus, means add or subtract, because you got to get two answers. That's negative 6 over 4. And that reduces to negative 3 over 2. And that was our two answers, if you remember. Here, remember, we had 5 and negative 1.5. Pause whenever you want. There's our two zeros, because this here is negative 1.5. Okay, and those are the zeros. 5 gives you 0, and negative 1.5 gives you 0. Awesome, quadratic formula. Great when you can't factor, but always try to factor. Okay, let's get a little more challenging. I put the 0 on this side. Sometimes you just see it over there. Sometimes you don't even see the y. Nobody wants you to graph it. They just say, tell me what's squared plus 3 times the number minus 7. You're like, oh, no problem. I'll just factor it. I'm the world's greatest factor. Nobody factors better than me. And I'm stuck. Because this is 7 times 1. If you put that, I'm going to mark it wrong because 1 and 7 cannot possibly make 3. This is this confusion, right? I'm Mr. Question Mark here. I'm totally confused. But there's got to be some answer. And in fact, there is an answer. This is a parabola. I don't know where it's at. There is some answers, but here's what's going on. These answers are irrational. Irrational, yeah, they're like 3.1252, you know, it could be some crazy number. Maybe it's like radical 7. I don't know. The only way to figure this out, not the only way, but the best way is the quadratic formula. What? Yeah, let's try it. Okay, so here's A. How about I circle them? A, we'll put a 1 there. There's A, there's B, there's C. Have you memorized the quadratic formula? You should. Okay, there's our quadratic formula. Let's put these in and we'll get the answers because I can't factor this. I'm so confused. Okay, so let's see. We'll put these in. Here's our numbers. Okay, here's A, B, and C. I even write it. A, B, C. Make sure they're in order. You don't, x squared, then x, then number. Sometimes you see a question and someone has a number on the wrong side and you got to bring it over to get them all in the right spot. Okay, so the opposite of B, so instead of positive 3, this time it's a negative 3. Whatever you see, it's backwards. Plus or minus, big square root. Square that, B squared is 9. Subtract 4, A, C. You can take a look at it, pause it if you want. Boom, 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 boom. Over 2 times 1. Okay, let's see what we get. Negative 3 plus or minus, and the bottom's 2. Let's see what we got in here. We got a 9. Ignore the negatives. 4 times 1 times 7, 28. 2 negatives. A negative times a negative is a positive. 9 plus 20, 37. Now I'm going, you're done. What? Yeah, you're done. That's it. You go, what? Yeah. I don't know what this number is, but you could stop right there. You could get in a calculator and go, what is negative 3 plus the square root of 37? You'd have to hit equals. Okay, divided by 2. Well, that doesn't help. I can hit decimal. That was the number, 1.54. Wow, no wonder I couldn't guess it. It's a crazy irrational number. And the other one I would subtract. So these are your two answers. And of course, you would try to figure out where the heck that is. You'd have to pull a calculator out to figure out where it is. Well, sort of. Isn't that the minus b over 2a? Isn't that the vertex right there? Negative 3 over 2, 1, 2. Right in here, negative 1.5. Of course, I don't know where on there, but it is a happy parabola. So maybe it's like down here somewhere. I shouldn't have put a dot there. And how far is it? It's over radical 36, kind of a little dot over this way and a little dot over this way. Yeah, don't put a dot there. Yeah, but that'd be harder to do. Okay, one last one, super challenge. All right, so here we go. I'm actually looking in the pre-calculus book right now. 2x squared minus 6x plus 1. Of course, this is the review chapter, the very first chapter in the first week or something. They're saying, you remember these, you know? Okay, so here's the pieces. Sometimes you'll see something on the wrong side, like the ones over here, and you have to bring it over. So there's A, there's B, and there's C. And we're going to put it in the quadratic formula. So we got to plug all these in, right? Okay, so I'm going to work it out on paper here. All right, so here's the problem we had. 2x squared minus 6x plus 1. There's A, B, and C. It's good to circle them because it's amazing how often people like, whoops, I put C in for B. You might go, oh, yeah, it happens. So circle them. I actually filled in some of the stuff that I already know goes here. Okay, so the opposite of B, instead of negative, the opposite, positive. This is really an opposite. Okay, B squared, negative times negative, positive. Always positive. Square it right away. Don't write negative 6 squared because then you might mess up. A is 2. C is 1. 2 times 2. Okay, you might say, oh, this is so easy, right? In fact, I think it was really cool when we got a radical in here and we got stuck. Okay, there's 6. 2 times 2 is 4. So inside the little scratch work here is 36. 4, 2, and 1. 4 times 2 times 1 is 8. Are you adding or subtracting? How many negatives do you see? Just 1. So that's a minus. 36 minus 28 is 28. And you might say, yay, I'm done because I don't know the square root of 28. You are not done. That is not the choice. You might be surprised that the answer is, when you look in the back of the book or on the worksheet, it's 3 plus or minus the square root of 7 over 2. This is the correct answer. What? This isn't simplified. You go, what do you mean? Like, would you write 50 over 100 as your answer? Someone says, no, that's 1/2. Oh, yeah. Remember our radicals? You have to remember everything you learned. I know that last question we were kind of stuck. We had like 37 or 23, you know. Or, does 28 break apart? Is there something times something is 28? Think about all the numbers you know the square root of. I know the square root of 1, and the square root of 4, and the square root of 9, and the square root of 16, and the square root of 25, and the square root of 36. What times what's 28? Is there something on this list? If not, you could say you're done. But 28, isn't that 4 times 7? This is the radicals we learned. Square root of 4, square root of 7 is the square root of 28. I put this one first because it's right here. What is the square root of 4? You're like, 2. 2 times the square root of 7. So now you got to rewrite this. 6 plus or minus 2 times the square root of 7 all over 4. Never cancel here because this is not a 28. This is the square root of 28. This is a weird decimal. You know, and you can't cancel here because this 4 is part of the whole thing. I see people try to cancel. No, you can't. Okay, so we can break that down. Now that doesn't look like the final answer, but at this point, who's over the 4? I am. No, I am. We both are. I'm over the 4. But so am I. I'm over the 4. So let's separate it apart. We have a 6 over a 4, and we have a 2 radical 7 over 4. The reason I'm doing that is because I notice these are all even numbers. And I know even numbers always reduce. 6 over 4 is 3 over 2. 2 and 4, they're regular numbers. 2 goes in there once, 2 goes in there 2. 2 over 4 is a half, so I'm going to put radical 7 over 2. I'll put a 1 there if you like, 1 over 2. We have the same bottom, so now you can put that back together. 3 plus or minus, I know you could say add or subtract, and 2 is the bottom. In other words, some people just do it right away. 6 over 4 is 3 over 2, but you got to cancel, you got to reduce here too. And that's the final answer. Challenging, isn't it? Yeah, that's a little more work. And I'm going to give you some of those in the worksheet. This was it in the pre-calculus book. So you say they couldn't stop there. They're like, that's this. And this is how we do it, college style. Your teacher next year will show you a whole bunch of work here. No. And that's your final answer. Ta-da! All right, so when you see these problems, it's your choice of how to do them. Okay, so here's the worksheet you're going to get. What do you call it when you spend 20 years in the 24th row of a theater? I'll just give you a little hint here. Sometimes what's the 24th letter of the alphabet? The 24th letter of the alphabet is X, just to let you know. If you got a ticket, it might say, I'm in row X. That'd be the 24th row. What if you spend 20 years of your life in row X of the theater? Okay, so here's the problems. You can solve them any way you want. You could do quadratic formula, but if you want, You could factor them. You could say, you know what? I think I could factor that. You could try it. You might get lucky and factor. You might say, you know, I might try to factor this. If you can factor it, you can save yourself a lot of time. But sometimes you're like, I can't figure it out. Down at the bottom are the answers where you put them. You notice the answers. See, that was a quadratic formula. Look, this was a normal answer. Some of them problems worked, and sometimes not. Sometimes you do the quadratic formula. If you know the square root of this, remember, you could keep going. You might say, oh, wait, I know the square root. What if the 6 weren't there? If the 6 weren't there, you'd go, wait a minute. The square root of that 9 is 3. Okay, negative 3 plus 3 over 10. And then you could actually get the answers. But sometimes you get stuck. And sometimes the radical breaks apart. So you could either factor or quadratic formula. In fact, a bunch of these at the beginning actually work. If I remember correctly, I think the first 5 can be factored. Notice here the 2's on the wrong side. Bring it over. Move the 2 over, call him a negative 2. Bring him over like negative 2 equals 0. So you have this, and negative 2. Right, here's another, I'm in the wrong spot. He belongs right there. Bring him over as a minus 9. We're good, we're good, we're good. Oh, there's another guy's lost. There's another guy's lost. Where does he go? He's a letter. He's in the middle, isn't he? Okay, so more challenging, even more mixed up. So ultimate challenge, you get 2 days. You can also see the answer, and I posted how to do some of the hard ones. And then you're going to get your test later in the week. You could do the test Thursday or Friday. All right, good luck, guys.